Hi and welcome to this Key Learning Initiative video. Today's topic is factorizing, and it's the difference of two squares. So before we get going, if you would please like and share and join my channel so that you can see more and more input. Right, but let's get going with our factorizing. So with our difference of two squares, we are looking at a basic formula: a squared minus b squared equals two brackets. In the first one it's a minus b, and the second bracket it's a plus b. Now whenever we considering factorizing as a difference of two squares, there's three important things we need to check. The first thing, it has to be a difference. It can't be a squared plus b squared. It has to be a difference. The second thing, there are normally two terms only. There are exceptions, but for the most part there are two terms. And thirdly, they both have to be squared. So it's a squared and b squared. Alright, so they both have to be squares. Those are the three criteria. Then we can factorize using the difference of two squares, otherwise we can't. So we check the three important things. If they're okay, we then have a few steps to do the difference of two squares. Step number one, write down two sets of brackets. Step number two, put a plus sign in one and a minus sign in the other one. Doesn't matter if you have a minus in the first bracket or a plus in the first bracket, it doesn't matter. Thirdly, calculate the square root of the first term and put it at the first term in each bracket. And fourthly, calculate the square root of the second term and put it in the brackets after the plus and after the minus sign. You'll see how we use these four steps quickly. Let's look at some examples. So, example 1, I have x squared minus 1. So I checked my three criteria. Is it a difference? Yes, it's x squared minus 1. Okay, there are two terms. And lastly, are they both perfect squares? Well, x times x gives me x squared, and so x squared is a perfect square. And 1 times 1 gives you 1, and so 1 is a perfect square, and so it does meet all of the criteria. Now we need to do our method or our steps. And so our first two steps, we write down two brackets and then we put a plus in one and a minus in the other one. Our third step, we look at the first term. What times itself gives me x squared? Hopefully you know it's x times x gives me x squared. Our last step, what times itself gives me 1? Well, hopefully you know it's 1 times 1. And there we have our x squared minus 1 factorized. Let's look at example 2. Here we have x squared minus 4y squared. And again we ask, does it meet our criteria? Well, it is a difference. There are two terms. From example 1 we've said x squared is a perfect square. Now we look at our second term. We have 4y squared. So what times itself gives you 4? Hopefully you can see it's 2. And what times itself gives you y squared? Hopefully you can see it's y. And so 4y squared is a perfect square, because 2y times 2y gives you 4y squared. Brilliant, meets the criteria. Step number 1 and 2, write down your two brackets, a plus in one and a minus in the other one. Then step 3, write down the square root of the first term at the beginning of each bracket. So what times itself gives me x squared? Hopefully you can see it's x. Then what times itself gives you 4y squared? As we said, 2y times 2y gives me 4y squared, and so I write 2y after the plus and 2y after the minus. There we go, factorized. Example 3. 9p to the power of 4 minus 16q squared. Straight away we ask ourselves, does it meet the three criteria? It is a minus, there are two terms, and now we need to see if both the first and the second term are perfect squares. So 9 is a perfect square because that's 3 times 3. P to the power of 4, is that a perfect square? Think about it. If I have p squared times p squared, that'll give me p to the power of 4. And so yes, 9p to the power of 4 is a perfect square. Let's look at my second term. I have 16q squared. Is that a perfect square? Well, 16 is 4 times 4, and q squared is q times q, and so it is also a perfect square. It meets all three criteria. Now we can do our steps. Step number 1 and 2, write down your two brackets, a plus in one and a minus in the other one. Step number 3, we write the square root of 9p to the power of 4 in the first term in each bracket. So the square root of 9 is 3. The square root of p to the power of 4 is p squared, and so we write 3p squared and 3p squared. Then we look at our second term, 16q squared. So 16, the square root of that is 4, and q squared, the square root of q squared is q, and so we write plus 4q, and then we have minus 4q. And there our example is factorized. Example 4, y to the power of 4 minus 1. Let's go through our criteria quickly. It is a difference, it's two terms, and lastly, are both of my terms perfect squares? So y to the power of 4, is that a perfect square? Yes, it is, because y squared times y squared will give me y to the power of 4. Is 1 a perfect square? Yes, it is, because 1 times 1 will give me 1. So it does meet all my criteria. So step 1 and 2, write down the brackets with a plus sign in one and a minus sign in another one. Then step 3, write down the square root of the first term in the first part of each bracket. So the square root of y to the power of 4 is y squared, and so we write y squared at the beginning of each bracket. Then we look at our second term, 1. The square root of 1 is just 1, and so we write 1 after our plus and 1 after our minus. Now normally we'd say, yay, we're finished. But let's look a little bit closer at the second bracket. The second bracket here has y squared minus 1 inside of it. Now does this bracket by itself meet the criteria? Well, it's a difference, there's two terms, and lastly, y squared and 1 are both perfect squares, and so this bracket by itself actually is a difference of two squares, and so we have to go a little bit further. Our first bracket, y squared plus 1, it's not a difference of two squares because it's plus. So equals, and we write down the first bracket. We can't do anything about that. Our second bracket, however, we know is a difference of two squares, and so now we follow our 4 steps. So step 1 and 2, we write down our two brackets with a plus sign in one and a minus sign in the other one. Step 3, what is the square root of y squared? It's y, and so we write down y at the beginning of both of our new brackets. Step 4, what is the square root of 1? It's 1, and so we write 1 at the end of each of our two brackets. Now again, we can say yay, but let's just check. Our first two brackets both have plus signs in, so it can't be a difference of two squares. Our last bracket, it is a difference. There are two terms, but our third criteria says, are they perfect squares? Now, if I look at my first term there, it's y. Y is not a perfect square, and so I cannot factorize that last bracket again, and so that is my answer. 3 brackets this time, not just 2. And so thank you for watching this Key Learning Initiative video on factorizing the difference of two squares. Please remember to join my channel. Please remember to like this video, and also please remember to share it so that more and more people can see this content. Also remember, your comments are really valuable to me, or if you even have any questions. Have a really good time and good luck with this factorizing.